Hi there, this is P6.2, Understanding Equality. So the main term in this unit is preservation of equality. There's actually only two vocabulary words for this unit, is preservation of equality is one, and operation, I think, is the other one. So pretty easy stuff. Three things that you need to be able to do. Explain what equality is. Well, here's a little hint. It has the word equal right there. So equality is just when two things are exactly the same, equal. I can show preservation of equality for, now here's the other word that we were just talking about, operations. There's only four of them. Adding, subtracting, multiplying, and dividing. The word preservation means you're going to preserve something, which means you're going to keep it the same. So if you were going to preserve some jam, you would put it in the jar and process it, or put it in the freezer, and it would keep the same forever and ever until you open the jar. So preserving just means to keep it the same. And creating equations. Remember that equations have an equal sign in them. If it doesn't have an equal sign, then it's just an expression. So something like 2a, okay, I need to quit using the mouse. I can't draw with the mouse. Okay, 2a, that is just an expression because there's no equal sign, there's nothing fancy going on. But if I said 2p equals 10, well, that's something we can actually figure out. It has an equal sign, and so we can use preservation of equality, what we're going to learn in P6.2, to figure out that p is actually equal to 5. Okay, so let's find out how. Think of an equation like a scale, and the bar in the middle is your equal sign. And there's a law. If you don't follow this law, the preservation of equality police will get you. They will beat you. It's terrible. What you do to one side, you must do to the other. So if I draw a horrible cat on this side, yeah, he's looking good, I must also draw the same horrible cat on this side. Excellent. So that means that what I've done to one side, I did to the other. Because if you were going to add a fat cat to a scale, you would have to add a fat cat to the other side to keep the scale in balance, right? So it works the same with math. If I'm going to put a 7 on one side, I basically have to put a 7 on the other side. But there's more than one way to write a 7. Could I not put a 5 plus 2 here? It's the same, right? 5 plus 2 is the same as 7, so everything is still equal. Let's try another one. I have 4 plus 2 on this side. So I could write 4 plus 2 over here. That would be the same. I could also write 6. I could also write 3 plus 3, because that's still 6. It's still the same. All these things are the same. Okay, so 5 plus 1, 6 plus 0. Okay, it's exactly equal to the other side, so my scale would stay balanced. So we have preserved the equality. So just remember your scale and this golden rule. What you do to one side, you must do to the other. So we have some rules for solving equations. Here's your operations. We can add, subtract, multiply, or divide both sides of the equal sign, both sides of the scale, by the same number. So what they're saying is, remember the scale that we had. I'll just draw a crude little model here. Okay. If we have a cat on this side and a cat on this side, what if I double it? What if I all of a sudden have 2 cats on this side with connected eyes? Yeah, he's looking good. Well, that means that I have to double it over here to keep my equation the same. Okay, because 2 cats here has to equal 2 cats here. or 2 cats here has to equal cat plus cat over here. There's different ways to write it, but basically we're doing the same thing. And so the law of preservation of equality says if you do something, if you multiply or you add to one side, that better be what you do to the other side or your scale isn't going to balance anymore. So now to solve problems, we want to perform the opposite operation. So you need to know a little bit about opposites. The opposite of adding is subtracting. The opposite of subtracting is adding. The opposite of multiplying is dividing, and the opposite of dividing is multiplying, right? So you know those two are opposites and these two are opposites. Remember that. So when you have an equation, here's your equal sign. This side has to balance with this side. Y plus 14 equals 20. So they're saying something, we don't know what, some number. We're going to use a variable because we just don't know what it is yet. Some number, we're going to add it to 14, and that's going to give us 20. So in your head, you might already be thinking, well, I know it's 6. I know it's 6. Great. The way to show this on paper is to show that if they have this part here that they've added 14, remember what we just learned about opposite. The opposite of 14 is minus 14. So we're going to subtract from both sides. Okay, 14 take away 14, they cancel out. Those equate to 0, so they're gone. And all that's left on this side of the equation is your y. And that's your whole goal in life, is to get y all by himself. Nobody else with him on this side of the scale. Nobody else stuck to him right here. Just plain old y. So let's go back to our golden rule. What we do to one side, we must do to the other. Well, they subtracted 14 right here. So what did they do to the other side? Same thing, they subtracted 14. So 20 take away 14, that's where we get our 6, and we're left with y equals 6. Okay, let's go across to the green example. Here's x. We want to get him all by himself, but right now he has this minus 120 stuck to him. So what is the opposite of minus 120? Well, the opposite of minus is plus, so they're going to add 120. What I do to one side, I should do to the other. These guys are gone because minus 120 and plus 120 cancel out. They're just 0, right? It'd be like adding 0 right here, which you really don't need to do. Okay, and on the other side, when we add 120, 80 plus 120 is 200. So x is equal to 200. Let's look a little further down in the purple example. You'll quite often see an expression like this, 3n. Do you see a plus sign anywhere in here? Or a minus sign? Nope. No, you don't. So what that means is when the 3 is stuck right to the n, there's nobody in between them and they're stuck right together, they're buddies, that means they're getting multiplied. So this is a way of writing 3 times n. But we don't use the times symbol anymore in grade 6. Because we start using variables, and then people will get confused and think, is this x the variable or is this a multiplication sign? What is this? So don't use multiplication signs anymore. We're going to use a bracket or just put the variable right with the number. Okay, so if I were to write 5a, that would mean a is getting multiplied by 5. With me so far? Okay, so let's go back to our purple example. 3n equals 12. This means 3 times n, something, right? 3 times something, number that we don't know, is equal to 12. So think in your head, 3 times what is 12? Well, I know it's 4, right? They've got the answer down there. But let's figure out how to write that down in our example. The opposite of multiplying is dividing. And so what they've done is drawn a fraction bar right there and a 3 underneath and said I'm going to divide this 3n, divide by 3. once you have the 3 on the top and the 3 on the bottom, those cancel out because 3 over 3 is just 1, if you know anything about fractions. Anyways, what you do to one side, you must do to the other. So on this side, we also have to draw a fraction bar and divide by 3. And 12 divided by 3 is 4. And what's left on this side? Just the n, all by his lonesome. And so you know you're done. Let's look at our last example. Don't worry if this is confusing you, because you're going to see this again in grade 7 and again in grade 8. Hopefully by grade 9 you've got it and you can do these lickety-split, but they're kind of fun. It's just a way of figuring out what number the variable is representing. Okay, this one, it says k divided by 2, because a fraction bar means divide, so k is getting divided by 2 right here. And when k got split in half, it ended up being 16. So we know that the answer is 32, because 32 split in half would be 16. But let's see how we write that down. The opposite of dividing, so I'm just going to rewrite it up here. The opposite of this symbol, that fraction bar, right, it means divide. So the opposite would be multiplying, and that's what they've done right here. They've multiplied by 2. Because when you have a fraction like k over 2, you're thinking, oh, this fraction, he's terrible. I hate fractions. I wish I could just get rid of him. I wish I had a 2 on the top so that I could just go boom, gone. And you can do that as long as what you do to one side, you also do to the other side. So if you multiply by 2 here, you need to multiply by 2 here. Okay, so 2 over 2 cancels out and all this stuff is gone. And you're left with 16 times 2 right here, which is 32. Okay, so let's try a couple of quick examples. First off, one of the misconceptions is that people have a hard time reading things like 4c. They think it's 4 plus c or 4 divided by c. Remember, when they're stuck right together, that means multiply. Okay, so over here in our example, 4 times c is equal to negative 40. So don't worry about the negatives. I think technically in grade 6 you don't have to multiply negative integers, but we're going to do it today for our little example because we're just that smart. So what do you think they multiplied the 4 by to get a 40? So you're thinking, well, I bet c is 10, and you're close, but remember there's a little negative sign right there. So technically the answer to number 6 is negative 10. So how did they do that? So think back to our fraction example. We have a 4 and it's stuck to the c. What do you wish you had on the bottom so that your c was all by itself? You wish you had a 4 so that you could go boom, boom, gone. Ha, take that 4. Okay, that's great, but what you do to one side, you must also do to the other. Okay, so if I'm going to divide by 4 over here, I need to divide by 4 over here. Negative 40 divided by 4. All that's left on this side is a c, and the answer to that is negative 10. Okay, let's try this next one. Negative 20 equals 4v. Okay, very similar to the last one. I wish I had a 4 on the bottom so I could go ba-boom, gone, see you later. Well, what you do to one side, you must do to the other. So I'm going to divide by 4 on both sides. Negative 20 divided by 4 is negative 5, and that's equal to v. All right, this next example, number 8, you'll see right there is a addition sign. So what's the opposite of addition? Subtraction. So I'm going to take away 2 on this side, and that gets rid of that, gone, right? And all that's left, my a just drops down right there. And what I do to one side, I must do to the other. So I'm going to subtract 2 on that side. 10 take away 2 is 8. Don't forget your equal sign. 8 equals a. Over here, my 2 is stuck to my k. So we need to multiply. or I'm sorry, it means multiply. The opposite of multiplying is dividing. So what do you wish you had on the bottom so that you could just have that k all by its lonesome? Well, you wish you had a 2. And then you can cross those out because they're gone. And what you do to one side, you do to the other. 22 divided by 2, what's half of 22? It's 11. Don't forget your equal sign. And you'll notice how I've done these is that equal sign just drops straight down, right, in every example, or fairly straight down. Okay, you keep your scale in the middle. Okay, this stuff drops down to there, and the k drops down to there, so that you're keeping everything kind of in a nice straight line. Good luck with preservation of equality. Remember, what you do to one side, you must do to the other.